Hello everyone. Welcome to the final lecture of the Introduction to Data Science module. We've been working on this Titanic machine learning project, and we're headed in the direction of making a web application where users can submit, say, their own test data, and our web application would respond with predictions for that test data. We've also been doing this from the perspective of if we were developing this in a professional environment where we perhaps had collaborators, how would we go about coordinating that? So we've been using the version control tool Git, as well as putting our code up on GitHub. Before we dive back into that, I want to address a very important topic, which is how to download the course material so that you can continue your education with the resources we've given you beyond the next couple weeks when we take down this training platform. So 2 weeks following the end of this week. So this week ends on the 25th of May. So on June 8th, we'll be taking down this platform and you will no longer have access to it. However, you can download all the notebooks that you have been using in this course. And you can run them on your own computer and continue your learning that way. And you'll still have access to the videos as well on YouTube. So first of all, in order to run Jupyter Notebooks on your own computer, you'll want to go to anaconda.org, click Download Anaconda. Anaconda is a distribution of Python. So Anaconda has packaged up Python along with things like pandas and scikit-learn and NumPy and matplotlib and all these tools that we commonly use for data science as part of Python. And they've packaged that all up for you so that you don't have to go and install these extra tools. They've also included the Jupyter Notebook server so that you can run Jupyter Notebooks on your own machine. Now what you'll want to do is click on the appropriate operating system for your computer, whether you're running Windows, Mac, or Linux. And this course is taught using Python 2. So you'll just click to download the Python 2 version. That will download a file to your machine. This will be some kind of executable file. You'll run that. And then if you're on Windows, you'll have an Anaconda folder in your Start menu. If you're on Mac, there will be an Anaconda directory in your Apps folder. If you're on Linux, you probably are familiar with running things from the command line, and you can just, after running the Anaconda installer script, you can just do something like Jupyter Notebook, and that will launch Jupyter for you. So because I'm on Linux, I can't demonstrate what this looks on Windows and Mac, but it's fairly straightforward. You download the installer, you run it. This will put a directory somewhere where your programs live, and you can go to that directory, run the Jupyter Notebook server, and run Jupyter Notebooks. So, how do we get the notebooks from our Jupyter Hub to our personal computer? We can open up a terminal emulator, similar to what we did to update data course as me and Zach developed more material and reorganized it. So we'll open this up. If you do ls, that lists the contents of the home directory, and we see there's the data course directory, which has all of our course materials in it. And what we want to do is zip up that data course directory. We're going to exclude certain files from the zip archive. Particularly, we're going to exclude any pickle files, but everything else we're going to include. We'll tell it that we want to recursively step through all the subdirectories. We want to zip up the data course directory, and we're going to put the output in datacourse.zip. Whoops. These go in the reverse order. So now we got a bunch of output, which is Linux telling us that it's zipping up all these different directories. And if we look back in our Jupyter Hub directory structure, we now have this datacourse.zip file. If we click that, it downloads to your personal computer. You can unzip it. So here I have my data course directory. I can extract that to my downloads folder, for instance. And if I navigate to my downloads directory and launch Jupyter Notebook, here I have my data course directory with all the content from data course. So here's all the lecture notebooks, and you can do this on your machines as well. I will post instructions to the message board detailing how to do this as well. And I will send out an email. Since this is a very important thing to make sure every student maintains access to the lecture material and all the notebooks, I want to make sure everyone sees how to do this and knows to do it in advance of the shutdown of the Jupyter Hub. Okay, so with that taken care of, we can turn back to our machine learning project. So, we're going to set up a web app. There is a Python web framework called Flask that is very good at good for creating web apps in Python. there is a tutorial that I like very much that introduces Flask on GitHub from a user named Bevatron, and she breaks down step by step how to get started with Flask, creating your own web app. And we're not going to go into quite so much detail as she does, but I highly recommend that you check out this tutorial if you want to learn how to create web applications in Python. Really, creating web applications requires a little bit of knowledge of HTTP, which is how computers talk to each other on the internet, as well as HTML, which is the language browsers use for rendering nice-looking websites. So behind this nice-looking website is a bunch of code. This is HTML. And our browser reads this and uses it to construct this kind of interactive visual representation for us. Those topics are a bit outside the scope of the course. We're not going to delve into them fully, but we will talk a little bit about how Flask works. If you're looking particularly for a resource on how HTTP works, HTTP is the protocol computers use for talking to each other on the internet. There's a nice free book from launchschool.com on HTTP. So you can Google Launch School HTTP book, and there's this beginner-friendly book on HTTP. And if you click that, click Start Reading, and you can learn all about how computers talk to each other on the internet. The main idea in Flask, if we open up this application.py file, is Flask provides a mapping of how a browser visiting different locations, different pages on our website should trigger Python code running in the background. So we have functions, Python functions, that are attached to destinations on our website. So if someone visited Index Lulu on our website, in the background, our server would run this Python code to respond to the browser visiting this web page. So that's the main idea behind Flask. Let's get started with Flask, our own example. So I've already installed Flask into our environment prior to beginning this lecture, but we would just do pip install Flask, and it tells us requirement already satisfied because I'd already installed it. And we're going to create a new app.py file, which will have or be home to our web app. Before I do that, I've also set up a new branch in our Git repository for working on this web app. So I'm going to delete that now because we're going to develop a new feature in our project. So we're going to be writing new code, and we're not really sure if this code is going to work or not, what we're going to want to keep, or what we're going to want to throw away. So we want a way to signal to our collaborators that this is new code, it's under active development, and we shouldn't be using this code in what we show to the public right now. This is just for us. It's under development. So the way we can do that is by creating a copy of our project called a branch that, separates off from our working version or sometimes called like the production version of our project code. And we'll call this web app. And this will be where we develop our web app. And, write that code. Everything is still here, but we're going to be adding more files as we develop this web app. So let's start by creating an app.py file, which will be home to our web app. And we're going to be using Flask. There's a little bit of boilerplate. We need to create our app. And when we run this file, we're going to want it to run the app. Now we need to add our first mapping of destinations that our browser could visit to Python code. What should the server do in response to a browser visiting our site? So the first place our browser might visit is just the root of our site. We sometimes refer to that as the index, because often people will have a page index.html where you're automatically redirected to if you visit the root of a site. And we'll do something very simple for now. We'll just return the words hello world. So if someone visits our site, they're just going to see hello world. So we'll save this, and then we'll run the app. Whoops, straight colon here. And when we run the app, Flask sets up what's called a development server, meaning my computer is now running a little web server that only I can access. And if we visit this address that it tells us it's running, we see that hello world here. So this is like the simplest web app we could possibly make. It doesn't actually do anything really. It's just a static page that doesn't respond to us any kind of way. It just says hello world when we visit it. But this is already a big step. We're using Flask to create a web server that executes Python code in response to our browser visiting some page. So we'll turn off that server for now. And we're going to check in this new development to Git. So first of all, I'm going to pip freeze to reflect the fact that now we're also using Flask. So I'll add requirements as well as app.py, and we'll commit this saying add hello world app. So those are just some temporary files. So now in our Git log, we see this new commit, add hello world app. This commit is only on our web app branch. If we check out master, the master branch, that commit doesn't exist. The master branch ends at readme. So this means that, if someone is adding in new features to the master branch, the master branch, which is public facing, it's what we might base our website on, or base whatever we're doing on, can proceed while we're working on this new feature. And once that new feature is ready, we can merge it into our master branch. So we'll develop this web app, and then once we're done, we'll bring it into the master branch in its fully working condition. So we'll go back to web app, which has that add hello world app commit. And something else to notice is if I check out master, there's not even an app.py file here. That app.py file only exists under the web app branch. So when I switch back to web app, this app.py file is here. So let's make our web app actually do something. So to do that, I'm going to make some changes that I'm not going to explain very much. But the end goal is to have the ability for a user to upload a test.csv file, and we will return predictions for whatever test file someone uploads, no matter what the content is, as long as it's consistent with our model. So we'll need a few things to do that. And in particular, we'll need our Titanic file that we developed for training our model and cleaning up the data and all that. So I'm going to move rather quickly through this, but it's a sketch that, hopefully illustrates some ideas of how web apps are set up. And this is really intended to be a jumping off point for your own explorations. I highly encourage you to go look up in tutorials for how web apps are designed. This is just kind of like an illustration. So I'm going to want to validate files. I'm going to want to train my model at some point. So here what I'm going to do is read in the training data. So I'm going to do sort of what I do in my Titanic file. I'm going to do all this stuff. So we're also going to be using pandas. So we'll add that to our imports. This one-hot embark and clean data and build model methods come from the Titanic module. So we have to say these things come from Titanic. Now to actually address what the what Flask should do when we visit the website. So for this, I'm actually going to pull up Flask. The Flask documentation has a lot of very nice tutorials on different kinds of like basic use cases or basic use cases you might encounter in a web app, like if users need to upload files. So this tutorial kind of explains the logic of how we might deal with file uploads from users. I am going to pull some specific parts. For instance, there's a little HTML here that's going to be useful. I try never to write HTML. It's a pain. So I always try and find HTML that someone else has written that I can simply copy. So this HTML is going to give us a little page where there is a form for users to upload a file. That's all this does. And if I, in fact, run our app and visit the site, we now see it says this upload new file, and there's like some buttons here for uploading a file. And that's all taken care of by this HTML. So this happens when we visit the site. That's known as a GET request. So if someone comes to this site by making a GET request, they see this HTML. We'll also want to handle the case when someone sends us a file, which is known as a POST request. So if we look back at this tutorial, we see if request.method equals post. So if someone is sending us data, like a file, we'll want to do something with that data. So we will store the file in this variable f. If there is a file and it's valid, let me change the name of this to valid file, then we want to use it to make predictions. So we will get our trained model by using this train model function that we defined earlier. We will create a pandas data frame out of the file that we have that the user has sent us. So test equals pd read CSV f. We'll store the passenger IDs for later. We will treat the test data to clean it up and one hot encode everything that we need. And then we'll create our result by predicting on the test set. And then we can return this data frame as HTML. So when someone sends us a file, that's going to be a POST request. POST is used for sending information to the web server. We'll take the file out of the request, we'll check that it's valid, and then we'll do all of our modeling to generate our result and convert that result into HTML that we can send back to the user's browser. Is there anything here that I am forgetting? I don't think so. Let's give this a shot. So Python app.py. Our development server is running now. Load up the website. We'll send it our test.csv file. And here's our predictions. So we see all the passenger IDs and our predictions whether or not that passenger survived. So this is a simple little web app. I could also make predictions on the training set if I wanted. I could try, but I encountered an error. So why did I encounter an error? Right, so our training set additionally has a survived column, which means that the training set has the wrong shape. So before we do all this modeling, we may want to check if survived in test we may want to drop that column if it's in the file that we upload. So if we try this again, now we can also send the training data if we want and get predictions on the training data. So nice simple little web app that exposes our machine learning model to users who might want to use our model to make predictions at the click of a button. So now we'll update our repository with the changes to app.py. We'll say add ML functionality to app. So now, what I might want to do is consider, now that I have a working web app, consider merging this into the master branch of my GitHub repository. And I could just do that from the command line, say like git merge, I could check out the master branch, git merge web app. And this would merge the web app branch into the master branch. But rather, what I will do is take this web app branch and push it to my remote repository which on GitHub now creates a new branch called web app, and I can compare it to the master branch and make what's called a pull request. So pull requests are particularly useful for collaborating with others on projects. They are essentially requests for your collaborators to review your code, assess whether or not it works, first of all, and secondly, is appropriate for merging into the project. So, I might say adds app.py, which launches, uses Flask and the ML model from Titanic.py to allow users to make predictions based on an uploaded CSV file. And I can create this pull request. GitHub will check if this can be merged in, whether it conflicts with the master branch or not. And if I were collaborating with people on this, I could request reviews from specific contributors to the project. So I could be like, at DZB, I would like for you to review this code. Since there are no other contributors on this project, I can't actually do that. But this is one way in which you can, request input from your collaborators and get some feedback on your code and development ideas for a project. And once your collaborators sign off, you can merge in that pull request with the rest of the project. So we'll go ahead and merge this. And now that it's merged, we can delete this branch. And now, on the master branch, first of all, there's no web app development branch anymore. There's just the master branch. And in the master branch is this app.py file, which has our web app code in it. So now, our local repository, our version on our computer, is different than the remote repository. In our master branch locally, there is no app.py file. So what we need to do is pool the updates from the remote origin repository into our master branch. And we see when we do that, it downloads from GitHub the changes and adds in these changes to our master branch. And since we're done now with the web app branch, we can also delete it locally. So that's a picture of how collaboration works and how development branches work. when we were developing this machine learning project, we additionally defined some functions that we might want to incorporate in the future, so into the way that we train our model. So we could, to start a new development branch to incorporate flag infant or extract titles in some kind of way into our machine learning model, and use that inside of our web app. And we would go through this whole process again. We would check out a new branch, maybe call it ML improvements, and in that branch we would augment our machine learning code to maybe improve our predictions, improve the model. And then once we felt confident that these changes actually improve the model and don't make it worse, we might move that into the master branch. So, let's see here. Got 20 minutes left. Are there any topics that I have left out? We talked about version control. We talked about virtual environments. We talked about GitHub and collaboration and what kinds of things we should include for our collaborators so they have all the tools they need, such as the requirements file that represents our virtual environment, as well as a README that tells them where to find the data and all that. We've done the machine learning example, and we've coded up a simple web app that exposes this to our machine learning model to the outside world for them to use to make predictions. I think this covers most of the topics I wanted to cover. There's one more topic that is useful to discuss in the context of project management, which is the idea of tests, particularly unit tests and the idea of continuous integration. So, an important part of collaboration and development is this pull request kind of workflow that I just illustrated, where I created a new development for our project, and I created a pull request where I might request that a collaborator reviews my code and checks that everything works correctly. And that's good, but often reviewing code is imperfect. Collaborators make mistakes, they don't realize something is broken, they don't do sufficient testing to make sure that it works, or simply, I don't have any collaborators for this project. How do I make sure that my code works, when I wrote it, and I might be prone to making the same mistakes in testing that I made when writing the code in the first place. I wrote the code. It looks okay to me. And the answer is that we should be in the habit of writing code that tests that our code is working correctly. So an important part of any project is developing tests. So I'm actually going to create a new branch called tests, and we're going to create a library of tests that should be run on our code when we make new developments to make sure that we don't break anything that's working. So I'm going to make this tests directory, and in tests, for now, I will say, we'll test our ML component. Testing so for now we'll start with the ML component. So we'll need to import Titanic. And we're going to want to test each function that we define in Titanic. So we're going to want to test clean data and impute by class and one hot embark. And we're going to want to write little functions that test all these functions with some known input where we know exactly what should be in the output. So for instance, def one hot embark so we're going to create a test data frame with a embarked column, which has a very simple, just 3 rows with values S, C, and Q in each row for the embarked column. And we want to assert that the result of Titanic.oneHotEmbark on this data frame gives us the result we expect, which would be a data frame with embarked S, one, zero, zero, embarked C, 0, 1, 0, embarked Q, 0, 0, 1. And when we run this testml.py script, we just want to run our tests. So far, we've just made one test, but we'll make tests that test all these functions in the titanic.py file. So I I don't have quite the right syntax here. I just need to test some, or check something very quickly. No. Ooh. Okay, so I'm not gonna waste any more time trying to get this to work correctly. I'm just gonna move my tests into the main directory of my project. So then I can just do import Titanic. Okay, so now this should work. No. This should work. So we got a value error, can only compare identically labeled data frame objects. So something about this didn't do quite what we expected. So writing tests also can require quite a bit of thinking to ensure that the tests themselves function correctly. Only compare identically labeled data frames. Are these not identically labeled? Seems like they are identically labeled. So I don't particularly care about the indices of these two things, so what I might try doing is just resetting the index for both. This also gives me an error. Why? This is also sensitive to the in order of columns. So do access equals 1. Now this works. So we're even debugging the tests. So now Now, when we run testml, now that we've sorted out the kinks in our test, it runs without giving us any feedback, which means that the test passed. So maybe we would put if so we could just put down here, print all tests pass. So if this were to fail for some reason, we would hit an assertion error here, and so that would halt execution and we would never see all tests pass. So we could go on to make more tests, like test clean data, test impute by class, test flag infant. So this is a particularly easy one, so I'll do it real quick. So we'll try an infant and someone who's definitely not an infant. And we'll add that to the tests that we run when we run this script. And this test passes as well. So we gradually build up kind of all the tests that we should have for all these different methods. And as we introduce new functionality, we want to make sure, first of all, it doesn't break anything that already works. So if we change like how one hot embark works later on, this test, we would run this test file and it would check that this test still passes and that one hot embark still gives us the functionality we want, even if we've changed this code. So tests are designed to make sure that the code functions correctly even if the code itself changes. And we, every time we make some changes, we run our test file to make sure that those changes still pass the tests. And this idea of building tests for each function is called unit tests, or unit testing, because we're testing the kind of units of our code, which are the functions. They're like sort of the smallest elements of our code. And if we do this continuously as we develop our project, it's known as continuous integration. And there's all kinds of services that plug into GitHub that will do this automatically for us as we create pull requests for new branches in our project. So this is another important development idea that I wanted to share with you as kind of like a picture or a sketch of how things tend to work in professional environments. So that concludes where I'm going to leave off with this lecture. And it also concludes all the lectures for the class. And I hope this was a useful way to conclude. And that it introduces you to a lot of kind of ideas that aren't necessarily part of data science, but illustrate how data scientists accomplish their work and what kind of workflows they use. So it's been a pleasure teaching you all. I know Zach shares this sentiment, and we hope the best for all of you in continuing your studies and developing your capacities as data scientists. And we hope that you all attain your career aspirations in that pursuit as well.